Good morning, ladies and gentlemen. Thank you very much for joining me in this behavior testing your container stock. I do hope you enjoyed the keynote. So let's get into some testing. If you have not watched my previous talk before, I am Janos and I am an educator by profession. I used to be a DevOps engineer, which is very much what this talk will be about. Nowadays, I make my living educating people. You can find me on these addresses, most prominently on my website, which is my last name.at. Let's take a look why I went into this topic at all, why I think that testing containers is important. So I built a project in my previous job which looked like something like this. It was a web hosting platform for WordPress and it was built on Amazon. So we used Route 53, the DNS service from Amazon, to send the traffic to our three main load balancers. These were built with OpenResty. If you do not know OpenResty, then it is a fork of Nginx that has some Lua modules built in. Now, these load balancers quite unusually queried a bunch of MySQL databases. And these databases were hosting the information where each customer's PHP nodes were located. And you have to imagine we're talking about well over 1,000 Docker containers that were running. When we built this, Kubernetes wasn't really a thing yet. So it existed, but it wasn't really stable. We couldn't really work with it in the way that we wanted to, so that we decided not to use it. So the MySQL database stored the location information where each customer's PHP container was running, so OpenResty could direct the traffic there. Now, the PHP containers were using a Ceph distributed file system, which would be worth its own talk with all its pain it's caused. And then the PHP containers, of course, sometimes restarted. So we used CloudWatch events to figure out, okay, what's going on in the cluster, if nodes are moving, etc. And this was watched by a component that we wrote ourselves called the ECM cluster manager. And this cluster manager stored this information in the MySQL databases, which of course was replicated. So you can see that this is quite a complex setup, and of course I left out a ton of things that are not relevant to this talk. For example, we decided to write our own SSH server, if that's wise or not. The source code, I might open source that at some point if you're interested in it. Now, today I want to talk about the three open resties right here, because that's quite an interesting topic. How did this whole configuration work? I'm not going to show you all the configuration because I don't want to bore you with a bunch of Lua code, but it's important to understand why I decided to go into testing containers. So if I look, for example, at the core of our configuration, it looked like this. I defined an upstream. An upstream in Nginx terms is a bunch of backends, and usually you would write a list of servers here. But since we have a dynamic number of servers, we couldn't really do that. So we added a default server to 127.0.0.1, which doesn't make any sense at all. And then we added this balancer by Lua file. And then, of course, we had another server stanza with access and rewrite, and we loaded the SSL certificates also using Lua. But the Lua code itself was, well, it's not pretty. Lua as a language, I think, well, opinions differ, but it's not pretty. So the point is that this Lua code was reading something from a database and then it's doing various rules. So the script itself was quite long. So the question comes, how do you test this, especially since it's so database heavy? You could, of course, write some unit tests for Lua. You could try and modularize it. But since everything is SQL queries, it's kind of hard to test in isolation. So I thought that, okay, we have to find a way to test these containers before they go into production, because of course the OpenResty instances were hosted in Docker containers and deployed using Ansible at the time. Now, of course, I would do it very differently. So I came across this piece of documentation, which is from the Docker Hub. And the automated repository tests work in such a way that if you look at here, the SUT container, you can basically write a Docker Compose file. And if you don't know, Docker Compose is a file where you can define multiple containers to run in parallel. And you can define a container called SUT, which will be run. And if that's run successfully, then the tests pass. If it doesn't run successfully, then the tests fail. So what I did is I built OpsBears, was the company I was running at the time. So I built this Docker Compose file, and you can see we defined multiple services, MySQL, PHP, and Nginx. And Nginx, of course, was the OpenResty installation, which was built, you can see that by the build stanza, from the current directory. So there was a Docker file in the current directory, which incidentally was the Docker file that was being used in production. And that, of course, would would then build the source code, because we had some custom modules that we needed to build in, etc., etc. So it was quite an involved process. And you can see that, yes, we do need testing for this because it is quite complex. The other components, such as a PHP instance, was basically to simulate a customer container, and the MySQL database was simply such that the Nginx instance could access the MySQL database and read some information. Now, the test container itself was quite simple. We did install a couple of utilities, such as we started from Ubuntu 16.04, which was the standard instance at the time. We did some upgrades, updates, etc. And we installed curl, wget, and MySQL client, because this was a shell script-based approach. Then we copied a couple of scripts into the container, and we set the CMD to the /unit test script. It was not really a unit test, but at the time it seemed appropriate. So first of all, we had a function to make querying the database easier. So this function in Bash is basically calling a MySQL command with the appropriate database and executing the parameters that are passed to it. If you're not a shell script magician, this is basically what it does. Now the script itself started with a MySQL dump. First of all, no, sorry, the script itself started with waiting for MySQL to come up, because in Docker Compose, you do not have a reliable way of saying, okay, wait for this container to be healthy and only then start the other container. This is not really a thing that you can do in Docker Compose. Now then, once the MySQL has come up, we would one other component that we had was provisioning the database. So that took a little time. And then we would do a MySQL dump. So once the database has been provisioned by this automatic process, which we wrote, then we would create a database dump. And then we had a for loop. This for loop went over all the scripts in the srv/test directory. Very simple, very efficient. And we would drop the database and recreate the database for every single test. Remember, this database, of course, is a test database that we're using. So this is running inside a Docker container, and we can throw it away afterwards. Then we would take the dump that we created before running our test loop and just simply pipe it back into the database. So we would recreate the empty database. Then we would delete var www/star, because some tests would create some files there. And then we would run the current test. So that's /srv/test/$test, which is the name of the test. Finally, we would check the exit code. So that's the $?. And in Linux terms, the exit code is what says, is it successful or not? And in this case, we say, if the exit code is not equal to 0, which is a standard exit code for not successful, then we would write something into the standard error, and we would also output the log that Nginx has written. So if there was a problem with the Lua script or etc., then that would be visible on the script output. Now, then we could use Docker Compose. We could just simply, like Docker Hub does it, we could just simply point it to the docker compose.test.yaml, say up -- build, and we would say abort on container exit. So if one of the containers exited, then it would abort. Excuse me. So the final piece of the puzzle is the exit code from SUT. So the Docker Compose script has an exit code, which is normally 0, but we would now take the exit code from the container called SUT. So how does a test look like? Let's take a look. First of all, we do an ECM, we do the query command, which we defined before, and into the ECM database, insert into, and we would add all the things that are required for creating a customer site and how to route it to the proper container, etc., etc. Then we would create the home directory for this customer, which is the example ID / domain name. And then we would create, for example, a sample PHP script. Now then, once the PHP script is created, we can now call the Nginx web service. And here's a little trick. We would call the Nginx web service by its host name, which is Nginx in the Docker Compose file, but we would pass the header, the host header, to the example.com domain. And this is important because otherwise we could also specify an IP address, but we don't know inside a Dockerized environment what the IP address is going to be. But we need to pass the host header because that is what Nginx will read to find the customer site. And we would save the whole result into /tmp/test.result. Now, after the test result is done, we can just read the test result, compare it to what we expected. And if it's working correctly, then we exit with 0, which is success. If it doesn't, if it's not successful, then we would just output some sort of an error message saying, hey, we expected this, but then we got something else. Now, what if we had something a little complex? So for example, we had more complex result than we expected. In this case, we could use the diff utility, which will print out the difference between two files. And this is what we could do. We count the lines that are differing. And if that's 0, then it's successful. Otherwise, well, obviously not. So, okay, here we are. We have done this and everything is working properly. And we could use this at the time. So this was okay. It wasn't perfect because we would never run this in an automated fashion. We would not be able to use it in a manner that we wanted to really automate the infrastructure. Part of the reason was because writing these shell scripts was very finicky, and we definitely needed to think about, okay, how is this whole setup working, etc. So bash or shell scripts were not really the right solution for this problem. So a couple of years later, which was recently, I think about a year ago, I was writing some Java application, and I was looking for basically doing testing better for this Java application. So I came across this thing. I knew it from the past, and now I really dove into gherkin. Sometimes you find this as cucumber, sometimes you find it as gherkin. It's the language itself is called gherkin. So how does this look like? Here is an example from a project that I've recently done. It's basically a definition language. I write feature subscription creation. That's the description. Then say, here's a scenario. And then I can list multiple scenarios. For example, creating a subscriber should succeed. And then I have 3 stanzas. One is given, which is a precondition to the test. When is the action that I do, and then I can check something. So in this case, when I have initialized the system, which is for my subscription management system, there's some initialization to be done. When I create a subscription with the email so-and-so, then the subscription should be created as unconfirmed. So this is a very high level business language that any manager can read. This is cool because you can just show this to a manager, and the manager will just read it and instantly understand, okay, what's going on here? Is this correct? Is this correct from a business sense? So this description should not contain technical stuff. This is a high level description of what the thing does. And then when you implement this, you can of course implement each of the steps. But to run this, I of course created a Docker container. I started from Python because in Python, this gherkin code is very easy to use. There's a package called behave, which does exactly what I need. So I started from Python 3.8 Alpine. This Alpine Linux is nice and small, and I added bash because I needed some shell script support in my container. Then, of course, I copied my source files, which contain the feature descriptions, into the op directory. set my work directory to op, and then ran pip install. Pip is the package manager for Python. Install -r. I passed it a requirements txt, which contained the list of packages that needed to be installed for Python to work. And finally, I gave it an entry point, which is a shell script. The requirements txt is quite simple. I added two packages, the behave package, which I already talked about, and the requests package, which let me make HTTP requests. And if I get to the correct slide, okay, so here's the shell script. The shell script is very complicated. It is basically, I started bash, then I do behave, and then I exit with the exit code of behave. So if it succeeded, the exit code will be 0. If it did not succeed, the exit code will not be 0. So how does a feature file look like? I do src/redirects.feature. My first attempt, of course, not very businessy language because I'm a tech guy, so I like to write tech stuff, but let's come to this later. Feature testing redirect scenario about me. So I go to when I send a request to http:/nginx/about me, then I should receive a 301 redirect to nginx/cv. So we're simply testing if the redirect is set up correctly. And you might think, why am I testing a redirect? It's very simple, because configurations and code is such in its nature that we mess it up. And funnily enough, when I went through my redirects list and set up all the tests, then I did actually find broken redirects in my config that were not working properly for all cases. So testing is useful because you can break stuff later on, or you can simply mess it up from the beginning, because we are human, we make mistakes. So tests are actually useful. Okay, so let's take a look at an implementation of such a step. We write this in a Python file, so /src/steps/web.py. We start with importing behave. This is the library that I already talked about, and we import requests, which is needed for HTTP. We use the step matcher RE, that's the regex step matcher, so we can put in variables, which is very useful. So I do, this is not an annotation. So in other languages, you would call it an annotation. In Python, this is a decorator. So I do an @when decorator. When I send a request to dot star, so anything there, and I see my slides mess the quotes up, but you get the point. Then I define a function which gets the context. The context is something that you can store data in between steps. And I get the URL, which was extracted from the when decorator above. And then I do context.lastResponse is equal to request.get, pass the URL, and I do not allow redirects because I want to capture the redirects myself. So let's continue. There is our code from before. I can also define a then stanza. So then I should receive a star, so anything redirect to, and again a URL in the quotes. And this is again a function. In this time, as we still have the context, we have the status, which has been extracted from the two brackets and the first two brackets, and then we have the target, which has been extracted from the second two brackets. And I say if context.lastResponse is none, then I raise an exception, because you can only use the I should receive a redirect. You can only use after a request. And then I do an assert. An assert will fail if the condition that has been passed is not true. So I do context.lastResponse.status code, which is the status code of the last response, not equal to what I was expecting. And I also do an assert on the last response headers location. So the location header, which contains the target of the redirect, if it's equal to the target. And it is that simple. So now I have a method where I can test my containers with behavior testing. So this in and of itself is very, very simple, and just about anyone can do it with a little bit of Python knowledge. However, I'm debating in myself if I should answer some questions right now, because there are some interesting questions there, but I think I will leave that to the end. Feel free to submit questions. So let's talk a little bit about test methodology. How does testing look like? This is my application. We have the user who accesses the application via some means, and that application talks to some external systems most of the time. So this is going to be other applications, it's going to be databases, etc. Of course, if you're building a lower level API, then your user is going to be a different application, but it does not make any difference. So when I want to test this application as a whole, what I do is I write some testing code, which does two things. First of all, it sends some test requests to the application and checks if the response is correct. It also has to somehow abstract away the external APIs and databases most of the time. This is needed to be able to reproduce the steps continuously. Because think about this, I was actually working on testing an application that was processing credit card payments. And this was incredibly hard to test because I took out my credit card and I could pay one, two, three times. And the fourth time, my bank would say, nope, you can't do that because fraud prevention mechanisms. So actually, we had to buy like 10 different credit cards to even test that application manually. But automated testing was almost impossible while connected to the external system. That's one of the reasons why this is a bad idea. The second reason is, for example, let's say databases. Actually, a decade ago, I had a colleague who was accidentally supplied the wrong database because the test environment, of course, wasn't as sophisticated as we now have with Docker Compose. So he supplied the wrong database and was accidentally running the test code against the production database, which is, you might think, silly, but it's even worse because it worked for a while because he had hard coded some IDs in his tests. And that worked nicely until there was a customer with that ID. So he submitted a very high ID and thought, okay, this was never going to be a problem. But at some point there was a customer with that ID, and then suddenly the test code started overwriting data in the production database, which was horrible. So that's why you basically want an automated way of disconnecting all external dependencies, because then you can run your tests as many times as you like without having to worry about external systems. If you're doing this testing really well, then most of your tests will actually run on your laptop while you're in the air 20,000 feet uh, on your way to America. So here, that's the thing about testing. You cannot test everything. You cannot test necessarily database queries. You cannot test if you, for example, you're talking to the AWS API or to my employee, the Exascale API. That is hard to test because you actually need a live production account. That will make testing very, very difficult and very expensive and also very slow. But most of the things you can test in isolation. And that's where Docker Compose comes in really, really handy. Now, of course, there's always the other case, but we will not talk about those. So these are kind of high-level integration tests. There is another kind of test as well, which you should be aware of such that you don't make the mistakes of confusing them. These are unit tests. You can imagine these units are tiny little pieces of the application. These can be one module, one class, and these are tested individually. But again, the dependencies are disconnected. This is usually a job for developers, so this is not something that you need to concern yourself with. In terms of a car, for example, you could say you can test the whole car by taking it for a test drive, but it will not tell you where the problems are. Or you can also test the car radio by taking the car radio out, hooking it up to a test bench, and then testing the hell out of it. So that will exactly tell you if there's a problem with the radio or not, because it's on a test bench. You know if the radio is at fault or not. The integration test's job, which we are doing right now, is to tell us if things have been wired together correctly. So, for example, if the radio has been correctly wired up to the CAN bus, because I think it needs it, or if the engine starts correctly, if the igniter has been, because maybe the engine has been tested individually, but you need to know if you turn the ignition key, if the engine will actually start, if all the wires are in place, everything's put together correctly. And that's the difference between a higher level integration test and unit tests. So with that in mind, let's take a look at our gherkin code again. I mentioned initially that gherkin is a business level language. So it should be on a business level. It should contain business language, and it shouldn't contain all the techie stuff that we usually want. This was my original redirects test. So if I now take a look at this, this has HTTP URLs in it. It has the redirect code in it. It has the other URL where it's redirecting to. So this is not a very, of course, some managers will understand this, but how about we rewrite this? Redirecting the old about page. When I open the old about page, then I should be redirected to the CV page. Very simple. This, of course, requires you that in Python, there needs to be a mapping from this business level language to the actual techie stuff. So you need to somewhere record the definition of the old about page. You need to record the CV page, what it means, and it also, the redirect should be recorded. So this is, how should I say? So this is an abstraction that is recommended that you do if you do behavior testing. Because the idea is that really a manager should be able to read this properly. Even a manager who doesn't necessarily have an idea about what's going on, you can just show the scenarios and then the manager can say if this is correct or not. Of course, it still happens that the manager needs to know the workflows or needs to know the application, but that's a different story. So as a last point, let's take a look at a little bit of more tools, Selenium in this case. So what happens if simply submitting a request is not enough, but you need to log into the application, you need to do some things in there, and you really need a browser because you have some JavaScript stuff in there. This is where Selenium comes in very handy. For example, you can basically launch a Firefox instance in the background, get a URL, then locate an ID, click on the button that is with that ID, etc. And you can basically click through in Firefox or Google Chrome or even Internet Explorer, Safari, whatever. You can click through. And Firefox, you can launch headless. So this can be inside of your SUT container. And you can test the whole application. And then it also comes to mind that you might even be interested in taking these tests that your developers really should write. And if they're not writing, then you can show them how to do it, and running these as part of a build system that not only tests the application itself, but also the Nginx configuration. So you get closer to your developers and you get some more co-working there. You can really test your application end to end, and you can be more confident that when you deploy your Docker container, it is actually working properly. So in my conclusion is that I think that since we are practicing infrastructure as code, this is something where we need to learn from developers. We need to learn from the good developers. We need to learn, okay, we need to test our containers, and manually testing is almost never okay, because you have a responsibility that your things are working correctly, and your Nginx configuration is basically code. Your PHP configuration is basically code. And if you're not testing it, you are relying on your intuition or your manual testing, and you can break it at any time. So I know this is a little bit of a shorter talk, but with that, I would hand over to your questions. And we do have some questions. The first question is, why have you chosen to do testing on a container level instead of some integration testing using, for example, Ready AIP? I will have to Google Ready AIP, and since I'm at home, I can do that. Okay, so here's the difference between Ready AIP or any full testing suite versus testing your containers. It's the difference between testing your whole application and testing a unit. When you test the whole application, it will tell you where that it's broken, but it will not tell you where it is broken. So you can test, for example, okay, is my application working correctly, but it's not telling you where it is broken. And the more fine-grained your things become, the better you can nail down where the problem is. So in my case, this unit is one container, because I am a DevOps engineer. I'm not a developer. Well, in this role, I'm not a developer. And when I test a single container, then I know exactly if the tests fail, then that is the fault of that single container and not something else. And that's very helpful to me when I'm developing more complex code, such as, for example, this open resty stuff, which, by the way, if you're interested in, hop on the Discord, which is on the screen right now. I'm happy to discuss this further later on. And of course, simple Nginx configuration, you probably wouldn't automate it tests in this fashion. But a higher level test, if I understand Ready AIP correctly, then this is a higher level test. First of all, it will not run offline. So you cannot build Docker containers offline or an environment where you just want to run tests quickly. Seems to be, from what I can tell, a full test suite which will basically run against your whole application stack as it is deployed in some staging environment. I might, of course, be wrong with this, but this looks like it's a full-on integration testing. Again, happy to discuss this later on my Discord. The other question that I have is what big companies, or not only big, use instead of Kubernetes. What do companies use instead of Kubernetes? Big companies tend to use Kubernetes because two reasons. First of all, they can pay the cloud providers, for example, Amazon, for running most of the Kubernetes stack. If you want to run it on your own, then good luck. I had a talk yesterday about K3S, which is a lightweight Kubernetes distribution that you might want to run. But running Kubernetes requires manpower. That means that we have calculated that running your own Kubernetes cluster in a production grade fashion with having the proper know-how to do 24/7, etc., costs you round about €1 million for a big company. On smaller companies, of course, you can do this on a budget, but generally for big companies, to be absolutely on the safe side, have the storage figured out, etc., you need about €1 million to run Kubernetes a year. If you're a smaller company, then you can, of course, go to Google and use their offering, or you can go to another cloud provider, because Google does not charge you for the Kubernetes masters, but you still need to run your Kubernetes worker nodes. So there's still some complexity involved, and most cloud providers give you an unopinionated Kubernetes setup. That means that you have to figure out how to do compliance rules. You have to figure out how to what kind of access controls to set, how to integrate that, etc. There is a ton of open source tools there, but as, for example, I explained in my talk yesterday, running your own, even having an idea of how this whole Kubernetes ecosystem works, there's so many tools that even I don't know. Even though this is kind of my job to know most of these things, because people ask me all the time. So instead of Kubernetes, what can you use? You can, of course, use a lightweight distribution such as K3S, MicroK8S, or etc. You can also go to Amazon has the Elastic Container Service, which is much simpler than Kubernetes, especially as a user. And you can also use Fargate, which gives you the ability to run containers without having to manage the servers. You can run a fully managed Kubernetes, where you just go to the cloud provider and say, hey, you need to manage everything. I will just use the API. Or you could use, for example, Docker Swarm. Or what I do with my personal website, which is up on my GitHub, feel free, is I use Docker Compose. I use Docker Compose because it's simple, it's dumb. You can very simply just use it. You can deploy with it to servers. It's not as fancy as Kubernetes. It doesn't have as many features. But if you just want to deploy to a single server, then that's just about fine. Okay, and I believe that is the last question. So, ladies and gentlemen, thank you very much for staying with me. Have a wonderful breakfast break. And as I said, feel free to follow me on various social media platforms. You can find my link on the slide below. And of course, join my Discord channel if you want to continue the conversation. Have a lovely second day of the conference and take care. Goodbye.